Okay, so today in Unit 1, Lesson 2, we're going to evaluate algebraic expressions. In previous semesters, I've had a warm-up of ordering a couple of fractions from least to greatest, but I think based on our work on fractions the previous day, we're pretty good. So, evaluating algebraic expressions, first thing you have to understand is what is an algebraic expression. And so an algebraic expression is where we set up a variable and some numbers, and we have an equal sign, and we solve for some things. In a chemistry experiment, a certain solution has to be cooled from 42 degrees Celsius to negative 11 degrees Celsius. What is the change in temperature in the solution? Well, what you know is that the solution is starting at 42 degrees, and it's ending at negative 11. Okay? And so you want to know what the change in the temperature is going to be. And so, really, if you were to create the algebraic equation 42 plus x is equal to negative 11, that would solve it. Now, you were also taught, that you could just subtract these two numbers or whatever to try to figure it out. But what I want you to start getting is the whole idea of what you need to know is this change piece. So how we get there is we either are going to have to do subtraction or some sort of solving. And so, if we were to solve this equation, we subtract 42, and so the change is a negative 53 degree change, okay? And so, that's just the earliest introduction to solving equations that you had at various points throughout late elementary and middle school. So in another experiment, a solution is 13 degrees Celsius. It has to be heated 25 and then cooled 12. What is the final temperature? Well, hopefully you're taking a minute and you're like, okay, so it's at 13. It's going to be heated 25, so I'm going plus 25. And it's going to be subtracted 12 to find the final temperature. So again, you're coming up with this algebraic solution. And hopefully you understand I'm using x as a variable to represent the part that we don't know. And so that when you do these things together, you get 26 equals x. We're going to save this one for class. If you want to give it a shot ahead of time, but we're going to talk about again how do we determine where what we don't know goes. And I think that'll be coming into play there, especially with in this question, where does the equal sign go? So, how we evaluate expressions, too, is when we substitute. It's very important that you remember parentheses when making substitutions, especially when you're using the TI-83. I'm going to do one of these with you, and then you're responsible for the last two on this slide, and then we'll talk about how we're going to pick up when you're in class. Just remember, whenever you do substitutions, you need to put in exactly what's given. So we're going to evaluate this expression if a is equal to negative 8, b is equal to a half, and c is equal to negative 2. Well, negative 8 squared. I substituted the negative 8 for a. 1 half, and then negative 2 squared. All of this is important, okay? So when we're in the calculator, and you could be doing this on your own, it's negative 8 squared times 1 divided by 2 times negative 2 squared. And I get negative 128. Let's double check our work here. Negative 8 squared is 64, so negative 64 times 1 half times negative 2 squared, which is 4. 64 times 1 half times 4 is 128. And since that negative sign is still out there, we end up with negative 128. So, again, you can see that the parentheses were absolutely critical in making sure that we evaluated these. So the key points for this lesson, and again, hopefully keep this around 5 minutes, was that we understand how we establish what we know and what we don't know, how we place variables, But then the important thing is, how do we substitute when we are given values for variables to help us solve using order of operations or PEMDAS that we know from before? When we pick up in class tomorrow, we're going to look at these two, check them over, and then we're going to talk about how this affects absolute values and roots, which is what we learned in the last lesson. If you have any questions, see me before class or shoot me an email.